everyone, welcome to physics class. This is Mom Chen and we are going to discuss about 3 topics for today.
What is this? Obviously an arrow, right? Well, probably not for those with the knowledge of vectors. Yes, by now we're very well acquainted with the idea of representing a vector by an arrow. Its length represents the magnitude of the vector and the arrowhead the direction of the vector. Now moving on, we're going to look at an interesting concept called components of a vector. To begin with, instead of diving right into the concept, let's first intuitively understand what is it all about. We know that any natural number can be written as a repeated addition of the number 1. 2 can be written as 1 plus 1, which is 2 times 1. 3, 1 plus 1 plus 1, that is 3 times 1, and so on. So any natural number is just the number 1 added to itself a few times. Similarly for vectors, there exists some special vectors similar to the number 1. These vectors, I hat, j hat and k hat are some examples of them. In the 3-dimensional space, they act like the number 1 for different directions like this. So for example, suppose we have a vector A in the 3D space. Then it can be decomposed into addition of these vectors like this. Don't worry about what all these symbols mean. We will understand them in detail. But for now, the point is that, similar to the natural numbers, a vector can be decomposed into a set of special elementary vectors. For example, consider another vector B in 3-dimensional space decomposed as this. Basically, we can say that these 2 examples tell us that any vector in a 3D space is just made up of these 3 vectors. Here, these individual vectors are called the components of the vector. The thing is that, as we learn more about vectors, we will see how important and useful this idea is. It makes dealing with vectors a lot easier. For example, suppose we want to add these vectors. Then we will see that to get the resultant vector, we just have to add the components of the vectors like this. Interesting, right? These components makes the addition of vectors as simple as adding numbers. This was just a glimpse of the whole idea to show you the bigger picture. Let's move ahead and understand what exactly the components of a vector mean. For this, we'll start by understanding what these special vectors are. These are called unit vectors. Consider a vector C represented by this arrow. Now let me ask you a question. What if we multiply this vector by this number 1 over magnitude of vector C? Can you tell me what would be the magnitude and direction of this vector? Okay, let's see. Remember, we have seen that multiplying a scalar lambda, that is a number lambda, by a vector A gives us a new vector. The magnitude of this new vector is equal to the absolute value of lambda times the magnitude of vector A. And its direction is the same as that of vector A if lambda is a positive number, or opposite to that of vector A if lambda is a negative number. So let's look at our question again. Here we multiply by the number 1 over magnitude of vector C. So the magnitude of the new vector will be this, which turns out to be 1. And since the number is a positive number, the direction of the new vector will be that of the vector C. So we get a vector with magnitude 1 in the direction of the vector C. This vector is called the unit vector in the direction of vector C. It's denoted by a symbol like a hat above the letter pronounced as C hat. Let's represent it like this with arrow. So a unit vector is simply a vector whose magnitude is equal to 1. This speciality of the unit vector is that it just specifies a particular direction. Therefore, the advantage of a unit vector is that we can use it to express any vector which is along its direction. Let's take a few examples and understand this. Suppose we have these two vectors D and E directed in the same direction as that of vector C. Now consider the vector magnitude of vector D times the vector C hat. As the magnitude of vector C hat is 1, the magnitude of this vector will be equal to that of vector D. And since the vector C hat and D are directed in the same direction, the vector D will be equal to this vector. Similarly, vector E will be equal to the magnitude of vector E times the vector C hat. And here as well, we could write the vector C to be equal to the magnitude of vector C times the vector C hat. So now the idea of a unit vector is very clear to us. But we still have to understand what component vectors actually mean. Let's see that in the next lesson. To stay updated and to keep learning such interesting concepts, do subscribe to our channel.